Can you start right now? Right. So the title of this presentation is Blending the REPL, the Editor, and the Source Code. And what does this even means, we'll see in a minute. But first things, my name is Maurício, Eduardo, Chicupo, Szabo. I am a motorcycle rider, as you can see. I also do Clojure, Ruby, JavaScript, and Clojure script. In fact, the tool that I'm going to show you today is written in Clojure script. And it's kind of interesting because in the beginning of my Clojure career, I didn't like Clojure script at all. And now half of my projects and more than half of my personal projects are in Clojure script. So it's kind of ironic. And as always, we are in a Clojure conference. I'm going to talk about the REPL at the beginning. And the thing is, Ruby, Scala, Clojure, they all offer REPLs. And in my opinion, the Clojure REPL is one of the best of all the languages that I worked with, save probably for Smalltalk, when everything is a REPL if you think hard enough. But anyway, a REPL is something that you evaluate things and will run the code and will present it for you in a printable way, let's say, something like this. So let's dissect the REPL and see what makes the Clojure the best one that I saw. The first part of the REPL is the read. You can read from the standard in, or you can type something and the REPL will read that input. The Clojure REPL offers a network REPL that can be an REPL or can be a socket REPL. The thing with the NREPL is that only works in Clojure. You can sideload to Clojure script with additional libraries, but for example, Lumo and Clojure CLR don't support NREPL as far as I know. Please correct me if I'm wrong. But the socket REPL is ubiquitous. Every new Clojure implementation will probably support socket REPL. And so I bet on the socket REPL for now. I'm betting on socket REPL for now. The next part is the evaluation part. Now this is a Ruby code. It's not a Clojure one. And this is one of the things that I think the language makes a difference. So you don't need to understand all of this. All you need to understand is that there's an initialize function here. And the thing with the initialize function is that you probably don't care about anything except the bar function. You want to evaluate this thing. And if you have to evaluate this thing, you probably will need to instantiate the whole class and pass arguments and then evaluate bar, and none of these will be in your final code. You are doing just this boilerplate to be able to evaluate something. And in the Clojure world, the things are shallower. It means that everything that you need to run bar, it's already there, are 2 arguments. So you don't need to instantiate anything and so on. Also, in the Clojure REPL world, you have the in namespace, in NS form. You can enter the namespace and evaluate everything there as if you were in the file. So you can evaluate private vars, private functions, and so on. So you can test everything that you want. In the Ruby world, you can do it, but you have to rely on additional APIs that will not probably, again, go to production. And the last point of the evaluation part is the homoiconicity. It means that the language is represented in the same data structures that it supports. So let's see this example here. If you have a range, it will print the same list that you are using to develop it. So you can copy-paste this, put a plus before the 0, and now you're summing all the 10 first elements of a range. And you can do this copy-paste development really easy with Clojure because everything that you evaluate will probably return something that is a valid Clojure data structure. Most of the cases, not always. Now the print part is also interesting because, as I told before, this is a data structure. And if it's a data structure, you can treat it as a tree. You can probably the inner parts of this range will be valid Clojure data structures too. So it's really easy to parse. It's really easy and useful to work with this kind of data. Now, with the unREPL inside the socket REPL and other optimizations and other code, new code in the Clojure 1.10, you can do even this. You can evaluate big things and will not blow up your REPL, will not blow up your terminal, will not blow up your editor. And then, if you want more, you can use these buttons here, or in the case of the unREPL, it will give you a function that you can call and it will give the rest of the data. So it's really useful to be able to evaluate things that are infinite, for example, infinite lists, infinite cycles, and so on, and not block out all our threads. So, the last part of the REPL is the loop. So let's loop down these things again with the tool that I'm going to present you today, that's called Chlorine. Chlorine is an atom package for Clojure socket REPL and Clojure script socket REPL. It works right now with Clojure and Clojure script Shadow CLJS, and also with Lumo. That is another implementation of Clojure script that doesn't use the JVM. I still haven't found a good way to program with Lumo, but I thought it would be really interesting to support something that, as far as I know, no one else supports. And first, a little bit of detour. The Chlorine is just a tool for Atom. It relies on another tool that I wrote called the REPL tooling. And the way it works is that the Atom plugin will ask to connect, will run a command in the REPL tooling word, asking to connect to a socket REPL. So far, so good. But it will also register some callbacks. In this case, on editor data, on end eval, and so on and so forth, in multiple other callbacks. The thing is, the REPL tooling will do all the connection to a Clojure socket, and will call this on editor data, on end eval, when some command have run. So what the REPL tooling will return to this call of connect is a list of functions, a list of commands that it supports. And then Chlorine can just, I don't know, call this evaluate block. And the REPL tooling will ask, okay, so what's the data that is in your current editor right now? What's the selection? What is the current namespace? And so on. And it will sideload these libraries. It means it will use these libraries if they are on your class path. For now, we are trying to figure out a way to download it and rewrite the class path if they aren't. So you don't need to add on your line profiles or depths.edn. And when these tools are present, you can use this throughout complete or other things. And why I thought in this architecture? It's mostly because it makes really easy to port for another editor. In this case, I am already experimenting with Clematis on NeoVim. So NeoVim, it's really a whole other story. It's really alpha right now. Nothing works correctly. But I can also evaluate commands inside NeoVim with the same machinery that Chlorine uses. Now then, let's revisit the read with Chlorine. The read, let's suppose you are reading right now, your source code is something like this. You can read from the selection. You can read the current block that you are, in this case the EDN read string only. Or you can read the top block. And why is it important to be this distinction? The reason is that when you are evaluating things, when you are developing things, I want to be as easy to evaluate some part of your code as it is to just save your file. So I don't want you to save the file to evaluate something. I want you to evaluate with the same easy. And that's the reason that probably if you are working on this guy here, you probably want to read all these guys or all the top level if there are some lattice statements or something. So it becomes kind of interesting to work with in this way. Now the eval part is also interesting inside Chlorine, because it will enter the current namespace in your file. It will issue the in-ns commands. So if you try to evaluate this code here, it will work. If you try to evaluate the same code on another namespace that doesn't require the Clojure string, it will simply blow up. And as you can see, there's some grayed out things by default, it hides or it doesn't give too much emphasis to the Java world. It will just give emphasis to the Clojure world, so you can see on your stack trace what is relevant to you, probably. Unless you're doing Java, of course. This is all disabled because it's Atom, and then you can just do a CSS class and everything is back to normal. Okay, so the print part, it leverages REPL, so it will do this elision here, and you can click this button here, and it will open your structure, so you can see the inner format of your data as deep as you want. That's the interesting part. And if you click this guy here or this one, they will evaluate the next steps. So you can evaluate infinite sequences inside the Chlorine, and we will keep evaluating as far as you want. Now, I want to step back a little bit and talk about the ideas of this project, because more than this tool, I want to show the impact of working with this tool have gone in my career, in my programming career, and exactly how are we working today and how can we work tomorrow if we think about this paradigm shift. And the thing is, sometimes when I am developing some software, I have this whole idea of there's the world, there's the real world, and I want to abstract it on my programming language. So far, so good. But the thing is, when I am abstracting things, I am abstracting in the concept of a language. So in the Clojure world, I was thinking about maps and vectors and lists and so on. And if I have a map and I want to transform it in another map to save on a database file or something, I need to think on how that map will be applied to functions, what these functions will return, and how I will implement all these things. This is like playing the computer. I am trying to imagine how the computer will behave with my data and with my functions, and then implement this and hope I am right. So Chlorine and all these tools that allows you to evaluate your code as soon as you can, they stop playing the computer part. You can just put data there and evaluate it. And if it's right, the computer will comply. If it's wrong, the computer will blow up. It does a better job than you on playing the computer because he is the computer, of course. So let's imagine how becomes a REPL-driven development with this context. Let's suppose I am defining a function called the mean, and the mean function is just a mean of two numbers. And if I want to implement this, I will probably today start with some seed data. So A is 10, B is 90, and then I will run this part of code. I will type it and run, and it seems that everything is all right. Seems like I got it right. So I'm gonna change the A to be 11, and this is probably not what I want. If I want to save in a database, the database will not understand the rational unless, of course, it's datomic or something that's Clojure aware. If I want to save in a spreadsheet or something, it will not understand this data structure. So the thing is, faster than I could write a test, I could test the real function with real data and see if it's working or not. And then I can write the right implementation. Nice. And now I will put all this code inside the mean. And I will just evaluate, just to be sure, I will evaluate mean to see if there's any syntax error. There's none. I will evaluate inside a comment this mean just to see if with another data if it complies. It does. Now I can transform this into a test case. I can copy paste the result from the other evaluation and transform it into a test case. And now I have frozen the implementation of mean to that specific part. Probably mean is not a good example because it's really, really simple. But if you are driving an API, if you have a REST API that's developed for another company, they have poorly documented features or no documented features at all, it's probably easier to just call the API, save the result with def or something, and then keep playing with the result until you are satisfied. It's probably even easier than writing a test case in the first place. So this is kind of interesting if you think about it. Now, Clojure REPL is just not good. It's an awesome REPL because if you have, let's say, this kind of namespace structure, and it requires two other namespaces that require this grand namespace, grandparent or something, there are tools that allow you to remove entire namespaces and now the code below it with, for example, remove NS or remove var. So we can remove vars, you can remove namespaces and so on in Clojure. And there are tools that leverage these abilities to parse your whole namespace. For example, Clojure tools namespace is one of these. And then they will create a depth graph for you. Right, so now if we change the sun namespace to require other namespace, what will happen is simple. Our REPL is not in sync with our source code, and we have to synchronize them. It's kind of tedious to keep evaluating things over and over again. And there are some changes that are incompatible. For example, if I renamed this alias to something else, and I renamed this alias for G, it will blow up saying that you can't rename things because evaluating new code doesn't destroy the old one. So Clojure tools namespace will detect this change and will remove the namespace and the others that depend on it, reparse everything and require everything in the same order. So the refresh is really fast. It is a good way to synchronize all your code with your REPL, and it works really well. Of course, you have to be aware that your code will be refreshed like this. There are codes that are not refreshable in this manner. For this, you can use require reload. It will not destroy anything, but it's good enough. You can use load file. Chlorine supports the 3. Or you can use Clojure script that it does this magic for you automatically. At least Shadow CLJS and Figwellman. So now, what I want to show is the workflow, the full workflow for REPL-driven development, plus something that I call discovery. The workflow that I use is that when I connect to my REPL, I will refresh everything. So now my REPL contains all my code that I'm typing right now. And I will create some functions that will start my whole system. And this means web servers, connections to RabbitMQ, and so on. And other that will stop everything. You can use component for it, you can use whatever you want, but the idea is that you can have these functions really easy. In the Clojure REPL is awesome because it allows you to run your web server inside the REPL, so everything that you are running in the REPL is in the context of a real application. To incorporate in your workflow, let's suppose I have a handler here, and I want to dispatch something differently depending on the request. Let's say I want to parse the headers and see if there's something different, and then don't render an HTML file. I will render a JSON or an EDN or someone. One of the things that I could do to understand what is this request format, because I have no idea what this parameter is look at the documentation. But let's face it, who does this anyway? You probably will do a println-based development, and that's fine. So with Chlorine, you can define the local rec to be a global one. There are tools that allow you to do that easily. I am just using a dev here to see how easy it is. And I will evaluate this guy. Sometimes I need to refresh everything. Sometimes I just need to evaluate, and then everything is fine. Then I will start my server, hit the page in some way, and now if I evaluate selection, I will get the whole request that came the time I run this code. And if I keep clicking, you will see that headers is a keyword, but all the keys in the header are strings. I would probably not be able to get it right for the first time. Now the good part is that I can, as my request is already persisted in a global var, I can write the code to parse the headers and to see everything and to, I don't know, render the different parts of my code over there and keep evaluating it until I feel satisfied, and then I just refresh everything, delete this def, and everything is working fine again. Now, discovery. Sometimes we have to do interop. There's no escaping on it. And when we are doing interop, you are almost out of luck. You have to go to Java docs or something. So, a real case that happened to me, I had to round this big decimal to 2 decimal digits. And to round it, I even had a slightest idea of what Java class this guy were. So I just typed type, and then it gives me the Java math big decimal. Now, if I click on this link here, he will give me the reflection of that Java, already Clojurified, as you can see. So it's already on S expression format. And if I keep clicking and clicking, I will probably go to this code here that sets scale. This looks promising. So there are 3 implementations. I would try this one that only expects an int, and I'm gonna put 2 there. And if I try to evaluate this thing, it will blow up saying that it needs rounding. And of course, it needs rounding. So the rounding mode seems promising right now. So if I expand this specific implementation, you will see that Java math rounding mode is a Java thing. If I click this one here, it will get me all the enumerators for that implementation, and I'm gonna use this half even. If I try to evaluate this, it works. So you see, I didn't even exit my editor. I simply didn't exit my editor to do this. I just keep evaluating, and clicking things and discovering how my runtime explains to me what's happening. So the runtime already knows all this information. I don't have to consult to a Java doc or something. That will probably not be the version that you are running right now. So this is really interesting in my workflow. Now, I am the author of Chlorine, but I can't imagine all the possible ways that people are going to use this library. I use prismatic schema. Most people use specs right now. And the thing is, I don't want to clutter the implementation with multiple implementations of libraries and so on, because these libraries will be outdated, they will change APIs, and I don't want to maintain this code. And also, I don't want to force anyone to use my library in the way that I use it. So, Chlorine is completely expensive. So you can expand the commands that you want in whatever ways you want. And in this case, I have an extension for Chlorine in my Atom editor that will parse the current source file. We'll get the source, we'll get the variable, the Clojure variable that's under my cursor. In this case, it's on the string, but I can point it to here. And need to rewrite this thing, rewrite person, to do something like, okay, is this a schema, prismatic schema validation, prismatic schema? If it is one, I'm gonna wrap around in a describe or an explain or something. And when I evaluate this code, it will return something like this to me. So this is incredible, because when I started working with Clojure, most people used schemas, and when you are in a new code base, you probably don't have the slightest idea what each schema does and what are the keys, what are the format of your data. And with Chlorine, you can see right in real time what's the format, what are the keywords, what are the types of these keywords, and then if you want to implement something, you already know that there's first name and surname right here. So there's no need for you to to try to discover, to try to imagine the format of your data. And this can be extended in any way. You can, for example, generate code for you, a test generator for you, based on that format of data, and then copy to clipboard, so we can use it on a test right now. You can do whatever you want, in fact, and that's the idea. Now, so far, everything that I showed you here is already on Clojure. If you download Atom and install Clojure right now, it will work. But there are also some experiments that I want to show. These experiments, some of them are partially implemented, some of them are not implemented at all, some of them are ideas. But the first that is partially implemented is promises. As I told before, I work lots of code in Clojure script world. And in the JavaScript environment, there's no way for you to exit an asynchronous function. So if you have an asynchronous function, you will not be able to def the thing or wait, ask for the runtime to wait so you can see the value. And it's really kind of hard to evaluate something and get back a promise that tells you nothing about the format. So one experiment is to evaluate a promise and return something like this. So far, nothing happened. It's the same. It doesn't tell you anything. But after 2 seconds, it will resolve to the format of your data. After, of course, the promise have resolved. In this case, it's 2 seconds. It couldn't resolve never if there's something that it's a bug or something. But the thing is, why doesn't this in the master yet? And the reason is that it's not that easy to leverage the Clojure script compiler and runtime. If you, for example, this only works in the browser target in Shadow CLJS because the node environment doesn't redirect the console, just the browser. So the browser environment redirects, node don't. Maybe there's a workaround, I don't know yet, but I'll figure out a way. And the thing is, if you reload the browser, this thing stopped working. So it's really brittle right now. But we're getting there. And these, as I told you, are experiments that will allow you to see your data faster. The other thing, as I told before, I was trying to implement this whole infrastructure in NelVim. And I had to implement a textual renderer. So the ones that you saw until now are HTML, because Atom runs HTML. It means that it's easily portable through Visual Studio Code, if I can figure out a way to display the results in line. But in the NelVim and other editors, you just have a textual representation. So the textual representation, as you can see, it's exactly the same as the HTML one, probably less powerful, but you can click things. In this case, evaluate code in the position of these things, and it will behave exactly the same. The idea is to behave exactly the same. Now, if you have this format of data, if you already have a textual representation of it, you can put it on Clojure, on the HTML renderer, some kind of button that will copy this code to clipboard. This will become really easy for you to do copy-paste REPL-based driven development. Like you evaluate something, it will give you back a Clojure data structure. You click on a button, you have copied to the clipboard, so you can just paste on your Atom and then keep running things and keep testing and so on. You don't have to select anything. This is probably will be in the next version or in the next few versions because it's almost done. Now, again, as I told before in the case of prismatic schema, I don't want to force anyone to use the ideas that I had. So, the most basic way of rendering something is to display the result. But maybe we can leverage some kind of tooling that will allow you to rewrite this renderer and not only display the results, but display, let's say, a graph. This will be great for data science. This will be great for a lot of other reasons. If, for example, this data structure were not a bunch of rendering of random numbers, it would be, I don't know, some number of bugs in a month. it would be wonderful to be able to plot in some specific structure that you want. Now, the idea is that you can expand the render in any way that you want. So for example, if you render an hiccup data structure on a React data structure, it would be great if you could rewrite the render so it would display the divs and other things here. If we can find a way to open an API for people to do that, maybe we could even get some very interesting ideas here. Who knows? Now, this is all that we have for Chlorine for now, but there's one more thing that I really found interesting when I was trying to figure out how to incorporate new libraries on it. And one of them is that we at the Clojure world, we already have code coverage. So I think Clojure is one of the mainstream languages that I use that have the best code coverage tool, that is Clojure. And what Clojure does is it will instrument your whole namespace with some kind of instructions. So when it runs your tests, these namespaces will be, these forms of your data will be instrumented in a way that they will save, okay, a test passed through here, another test passed through here, and so on. And will generate an HTML file like this. Now, if you look at this structure of this HTML file, the red here, that you can read too little, the red line, it means that this code is not covered at all. So it's like a code coverage in any other tool. It's not covered, no tests have passed through this, please fix it. The green part, it means that your code is covered, everything is working fine, you don't need to do anything else. Now, the interesting part is that orange part. I hope that I'm getting the colors right because I'm colorblind, but I think I am. Okay, so the orange part, and as you can see, I can define it, I can see the difference between them. It means that your code was partially covered. It means, for example, in this case, this is one of my libraries. I know that I didn't test the second case here of OR. I just tested the third case. So if you hover your mouse over there, it will say, okay, this part here, this line of code have, I don't know, 70 forms, and you covered, I don't know, 30 of them. And it's a great tool. It will probably not match the number of forms that you have because it expands macros and expects you to cover all the code paths in the expanded format. So it's really, really powerful, a really powerful tool. But the idea is that if you look at the implementation of Clojure, it doesn't expect anything about how do you want to instrument this thing. So maybe we could do something like this. We instrument your code in some ways, and then you run your web server and hit a keystroke or go to a new URI or something, and we'll render in your editor exactly the function that handled that request. It's not really that hard. We just need to work around some way of displaying this in a better way. But maybe we can do even better. Maybe we can just instrument something and keep it instrumented. And then let's suppose this is web server, and I hit a page, web page. I open the web page, and we will render this on the editor. What this is saying to us is, it's being handled by handle the thing. This code passed through the handler. This one here didn't pass through, so it means this was not the if branch that was run, it was this one. So now you know, by definition, what lines of code does that part of your application is running. And it's a great idea for example, newcomers to a project, or to onboarding or something, you don't need to explain them anything about the system, just how to run the tool. And then, okay, now let's suppose you can drive around and see what happens in your editor. Now, if you keep it instrumented, being instrumented, let's suppose you click on a button on this web page or a link or something. Maybe it could complement that information saying, okay, right now I'm still using the head of the thing, but now I pass it through the query, and there's also this other function that hit when you click at that button. And this is kind of great in a lot of ways, especially because if you look at this, if you try to evaluate this, it's not a valid Clojure code because query things should be on top of handle this. But this is the, let's say, the timeline of how things are running. And it's interesting if we could leverage this tool in a way that we can see exactly how the code is running and see in a new light our code. If we can somehow even link this guy here with his source code, we can do a development here without imagine when your source code is. You can save this guy, you will save your current source code, reload everything, and everything would be fine. You wouldn't have to imagine or get all the boilerplate of code before and code after and so on to work on correcting a bug, something that should be simple in theory. Now, this is all I have for today. Before I leave for questions, I have to get the biggest thank you. Thank you for Sean Corfield for starting the beta tester and being the primary beta tester and fixing lots of bugs and helping develop the project. Thomas Heller, because of the Shadow CLJS. Without Shadow CLJS, none of these would ever exist because it's really easy to develop something. In fact, I use Chlorine to develop Chlorine inside Atom. It's a kind of brain surgery in yourself because you are running the tool that you are writing to run the tool that you are writing right now. It kind of gets confusing, but it works. And Christopher Grant for the UnREPL project. Without UnREPL, everything will be really, really difficult because Clojure is not really that easy to parse things. Have you ever tried to make a keyword with spaces on it? It's a valid Clojure code. It renders something that's not readable for the reader. So UnREPL does all the magic of discovering these things for us and rendering something useful. Now, everyone at Chlorine channel, I wouldn't be able to name all the people that helped me, but there are a lot of them, and people of the Clojure Brazil Telegram group to point me to some libraries and other tools that I'm using in the project. And that's all. Thank you. Do we have time for questions? No? You? Is there a microphone there, or? Ah.
Hey, great tool, great talk. I wanted to ask, how do you get into building Chlorine? Like, there was no tool for Atom, or you wanted to do a side project? How do you get into doing this?
Oh, great. Chlorine started as an experiment if I could do Atom development with Atom plugin development with Clojure script. And the thing is, it's really hard to develop Clojure script with the existing tools for Atom because you have to sideload a REPL, and if you have mixed Clojure and Clojure script, you would have to keep switching REPLs and exiting. So I wanted a better way, some way that I could define that, let's suppose this is a Clojure script file, so I'm going to evaluate it as a Clojure script. This is a Clojure file, I'm going to evaluate it as Clojure. This is CLJ. I don't have any idea how to evaluate this, but I prefer Clojure or I prefer Clojure script. So the idea came because I saw that it was really hard to do all this leverage and all this switching, REPL switching and so on. I tried to hack something around proto-REPL, but it was brittle and broke everything, and it was full of hidden state. So I thought that maybe starting a project that was in Clojure script, so I wouldn't have the idea of picking up of Clojure code, parsing as EDN, transferring to JavaScript, reparse it at a Clojure, and render back in the Atom. So I thought it would be a great an experiment, and it grew up from there. Anyone else? Okay, thank you.